At 0420 hours, a thick blanket of mist cloaked the sea south of Truk Lagoon. The crew of the Imperial Japanese Navy submarine I-181 had been submerged for nearly 9 hours. Inside the steel hull, humidity hung heavy. A mixture of diesel fumes, sweat, and fear. Every man listened to the rhythmic hum of the electric motors, praying the sonar pings would stop. But then it came again, a sharp metallic ping echoing through the hull like the toll of a funeral bell. The helmsman froze. The sonar operator's face turned pale. "They found us," he whispered. Imperial Japanese Navy Patrol Report, Jan 1944. Moments later, from above, 4 American destroyers fanned out in perfect coordination. Their propellers churned the dark sea into froth. On board USS Fletcher, sonar screens flickered with the faint trace of a submerged target. 500 yards off the bow, depth 230 feet, bearing steady. The officer in charge didn't hesitate. Patton Baker, fire depth charges, U.S. Navy log, Jan 1944. Explosions ripped through the deep, concussive thuds rolling like thunder underwater. Each blast pushed walls of pressure through the ocean. Inside I-181, gauges burst, lights flickered, and the hull groaned. One young sailor screamed as pipes ruptured and water sprayed across the control room. The commanding officer shouted, "Crash dive deeper!" But the submarine had already been locked in by the enemy's new precision. American sonar, now far beyond anything Japan imagined. U.S. Naval Sonar Evaluation Report 1944. For years, Japanese submarines had stalked the Pacific with near impunity. In 1942, they prowled close to Australia, even shelling the American west coast. But by 1944, everything had changed. U.S. destroyer groups, once clumsy in anti-submarine warfare, now hunted with mathematical precision. It was not luck. It was technology, perfected through months of sleepless nights in laboratories and naval yards from San Diego to Boston. Bureau of Ships Memorandum, Deck, 1943. The sonar ping, once just an experiment in echolocation, had become a deadly symphony. The Allies called it ASDIC, a term born from British research but refined into American engineering genius. Sound waves pulsed through the sea, bounced off steel and returned as echoes on glowing screens. For Japanese submariners, it was as if the ocean itself had turned against them. Office of Naval Research Report 1943. Every Allied ship now carried trained sonar operators, men who could read the difference between a whale, a thermal layer, and the heartbeat of a submarine. Their precision turned chaos into order, guesswork into geometry. With each ping, they painted an invisible picture beneath the surface. The destroyer became a hunter. The submarine, once the predator, became the prey. U.S. Destroyer Squadron Training Manual, 1943. Japanese doctrine had not prepared for this. Their submarines were designed for long-range reconnaissance and capital ship attacks, not stealthy defense. The Imperial Navy believed their greatest strength lay in courage and cunning, not electronics. Their commanders had dismissed American sonar as primitive, but now that arrogance was sinking ships faster than torpedoes ever could. Combined Fleet Staff Diary, Feb 1944. By early 1944, U.S. sonar crews operated with frightening synchronization. Destroyers no longer wandered the ocean searching blindly. They moved in wolf packs of their own, 3 or 4 ships coordinating sonar data over radio. If one ship lost contact, another picked up the signal instantly. This was the birth of coordinated anti-submarine warfare. U.S. Navy Operations Bulletin, 1944. On the morning of January 16, 1944, I-181 tried to evade. The commander ordered a silent run. All machinery stopped. The crew waited in complete darkness, but the sonar operators aboard USS Fletcher were relentless. They adjusted gain, read the faint echo shift, and predicted the submarine's drift. It was like listening to a heartbeat through miles of water. Then another pattern of depth charges rolled off the rails. After-action report, Destroyer Squadron 21, Jan 1944. Inside I-181, chaos reigned. Bulkheads began to buckle. The chief engineer, covered in oil and seawater, tried to maintain ballast control. The captain ordered surface and fight, but as the submarine rose, a final charge detonated near the stern, tearing open the pressure hull. The sea flooded in, extinguishing the lights forever. Imperial Navy Casualty Roll, Feb 1944. Above the surface, American sailors cheered briefly, but there was no joy in the victory. They knew each sonar contact meant dozens of men dying in the dark. The Pacific was becoming a graveyard of iron. Yet these victories were essential. Each Japanese sub destroyed meant safer convoys, fewer supply losses, and momentum for the coming island invasions. U.S. Navy Statistical Summary 1945. The Japanese Navy could not keep up. Replacement submarines rolled out slower than the Americans could sink them. Their sonar technology lagged by years. Their hydrophones, limited by low sensitivity, could not detect Allied ships until it was too late. Even worse, Japanese sonar operators lacked standardized training. Each boat ran its system differently. Naval Technical Mission to Japan 1946. Meanwhile, in the United States, scientists and engineers were refining sonar weekly. Laboratories at Harvard, Bell Labs, and the Naval Research Laboratory raced to enhance signal clarity, beam focus, and depth calculation. The QHB sonar set, introduced in 1943, became the destroyer's deadliest weapon. It could lock onto a target's bearing and hold it during attack runs, guiding depth charges to lethal accuracy. Technical Manual TM 9294-1943. These invisible battles beneath the waves were not just contests of bravery. They were wars of mathematics, acoustics, and human nerve. The Japanese submariners were brave men, but they were trapped in a war that had moved beyond courage. Against the relentless rhythm of sonar pings, even the steadiest hearts faltered. Psychological Evaluation of Submarine Personnel, U.S. Navy, 1944. By mid-1944, the tide of the undersea war had turned completely. Nearly half of Japan's submarine fleet was destroyed. Their supply lines starved, their fleet scattered, their morale broken. The sea that once offered concealment now betrayed them with every echo. U.S. Strategic Bombing Survey, Naval Warfare Section 1946. Still, beneath the statistics and reports, one truth remained: the battle between technology and instinct. The sonar, cold and precise, had become an extension of human will. It was no longer about who fired first, but who heard first. Naval Engineering Review 1944. As the Fletcher-class destroyers continued their patrols, the ocean itself seemed quieter. Japanese transmissions grew rarer. Commanders noted no contact for days. But deep in the Pacific, the last few submarines were still moving, silent, hunted, waiting for a miracle. They did not yet know that the Americans were preparing to unveil an even more terrifying improvement, a weapon that could listen, think, and kill faster than ever before. At 0700 hours, aboard USS Nicholas DD-449, sonar screens glowed in the dim red light of the control room. A faint echo appeared, pulsing irregularly, deep beneath the thermocline layer, too consistent to be a whale, too deliberate to be debris. The chief sonar operator leaned forward, hand hovering over the gain dial. Target bearing steady, range 1,200 yards. The officer nodded once. That's no rock. Destroyer squadron log. Feb 1944. What the crew didn't yet realize was that the signal they were tracking came from RO-110, a Japanese submarine sent to intercept U.S. transports near Eniwetok. For months, Japan had struggled to keep its sea lanes alive. Its fleet submarines, once symbols of imperial pride, were now relics of outdated doctrine. Their crews lacked advanced sonar. Their periscopes leaked. Their batteries were failing after years of use. But they still sailed, because Tokyo demanded they fight to the end. Imperial Navy Submarine Directive, Jan 1944. What doomed them wasn't bravery or even numbers. It was technology. The U.S. Navy's sonar revolution came from an unlikely partnership between scientists, engineers, and sailors. In 1941, before Pearl Harbor, a group at Bell Telephone Laboratories had begun experimenting with piezoelectric quartz crystals, trying to create sound waves powerful enough to map underwater objects. By 1943, under Navy contract, they developed the QHB sonar, a system that could both emit and receive sound waves on variable frequencies between 14 and 24 kHz. This range, they discovered, could cut through thermal layers that often shielded submarines from detection. Bell Labs Research Memo 1943. The result was astonishing. The U.S. Navy could now track a submarine through evasive maneuvers, turning, diving, even releasing decoys. The sonar wasn't static anymore. It could adjust dynamically, painting a continuous picture of movement below. Engineers called this bearing hold, but sailors called it something else, deathlock. Bureau of Ships Report 1944. To make it work in battle, American ships needed trained ears. The Navy created sonar schools at Key West and San Diego, where hundreds of operators learned to interpret faint echoes as if they were musical notes. They could distinguish between a torpedo tube, a propeller shaft, or a changing depth rudder angle just by sound signature. We could hear them sweating, one sailor later recalled. Dramatized Composite, U.S. Navy Oral History Collection, 1947. The Japanese had no equivalent training system. Their sonar systems, mostly derived from German Type 121 hydrophones, lacked the processing power and precision. The Type 93 and Type 95 subs could dive deep, some over 300 feet, but they couldn't hide. Their sound profiles were loud, their hulls uncoated with any sound-dampening material. Every ping that hit them echoed back like a drum. Naval Technical Mission to Japan, 1946. By February 1944, the Americans introduced an even deadlier combination, sonar-guided depth charge patterns. Instead of random scatterings, destroyers launched charges in geometric grids based on sonar triangulation. The system, known as a tack plot, calculated the submarine's predicted path and automatically adjusted firing angles. This was pure engineering brilliance, created by a team led by physicist Dr. Harvey C. Hayes at the Naval Research Laboratory. NRL Progress Report 1944. Meanwhile, another invention joined the hunt, the Hedgehog anti-submarine mortar. Unlike depth charges, which exploded at preset depths, the Hedgehog fired 24 contact-fused projectiles in an arc ahead of the destroyer. They exploded only on impact, giving sonar operators immediate feedback. If nothing detonated, they still had their target intact and could strike again. U.S. Ordnance Pamphlet No. 866, 1944. The Japanese submarine RO-110 learned this horror firsthand. On February 12, 1944, it tried to sneak toward convoy Tu-2 south of Eniwetok. The sea was calm. The crew believed they were unseen. But USS Nicholas had already locked on with its QHB sonar. The operator traced every shift of the submarine's course. Contact bearing 270, range 1,000 yards closing. The destroyer charged ahead. Fire, Hedgehog! Dozens of spiked bombs splashed into the water in perfect formation. Then silence for 8 seconds. And then thud, 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 thud. 4 detonations. The crew cheered. The sonar screen went blank. After-action report, Destroyer Squadron 21, Feb 1944. Nothing remained of RO-110. No survivors. No wreckage. Only an oil slick. American destroyer crews now spoke of sonar kills with awe, not of the men who died, but of the precision. What once required dozens of ships and luck could now be done by one well-trained destroyer in minutes. The U.S. Navy began calling it controlled destruction. Fleet Tactical Bulletin to 1944. But behind that precision lay thousands of unseen hands, engineers, draftsmen, machinists, and women in factory lines. At Western Electric's Kearney Works, rows of workers soldered sonar transducers under magnifying lamps. At General Electric, technicians calibrated amplifiers so sensitive they could detect echoes a mile away. At Raytheon, physicist Harold Edgerton refined the strobe circuits that improved pulse clarity underwater. Their efforts turned science into victory. War Production Board Report 1945. The Japanese, isolated and under blockade, could not replicate this industrial miracle. Their few surviving submarines operated without replacement parts, using recycled vacuum tubes and makeshift rubber seals. Their sonar systems degraded. The once proud undersea hunters were now ghosts, limping through a hostile ocean. Imperial Navy Engineering Memo, March 1945. Even German assistance, sent via radio blueprints for advanced U-boat sonar, arrived too late. Japan lacked the materials and infrastructure to mass-produce such devices. The U.S. advantage in acoustics had become overwhelming. Every convoy, every task force, every amphibious landing now sailed under an invisible shield of sound. U.S. Navy Research Division Summary, 1945. In one of the war's most decisive anti-submarine engagements, the Battle of the Philippine Sea in June 1944, Sonar-equipped destroyers formed a defensive ring around the carriers. As Japanese submarines attempted to penetrate the screen, sonar operators aboard USS Melvin and USS Haggard detected them miles away. Coordinated over radio, they attacked in succession, forcing the submarines to dive deeper, beyond safe limits. Hulls cracked under pressure, marking the quiet end of Japan's underwater force. Task Force 58 Action Report, June 1944. A captured Japanese officer later confessed, "We could not understand how they always found us. We thought the Americans had trained whales." Dramatized composite. Interrogation transcript Naval Prison Guam 1945. By autumn 1944, the effect was total. 90% of Japan's submarines were destroyed or immobilized. Their command admitted defeat in silence, shifting remaining boats to cargo duty. A humiliating transformation from hunters to haulers. But even those were lost, hunted by sonar's unblinking precision. U.S. Strategic Bombing Survey 1946. The battle had changed from guns and torpedoes to science and circuits. In American naval academies, officers began teaching sonar tactics as acoustic geometry. A new breed of sailor emerged, part warrior, part scientist. They didn't fight with rifles or courage alone, but with oscilloscopes and equations. Naval Training Bulletin 1945, yet even in triumph the cost was heavy. Hundreds of American sailors lived under constant tension, listening for hours, knowing one missed echo could mean death. Fatigue was chronic. Some operators began hallucinating phantom pings. Medical officers called it sonar fatigue syndrome. U.S. Navy Medical Bulletin 1945. Still, the war demanded perfection. Each successful hunt pushed the U.S. Navy closer to the home islands. Each echo marked the death of another Japanese submarine and another step toward Japan's isolation. By December 1944, sonar no longer just hunted. It commanded the sea. Destroyers moved like a single organism, guided by sound alone. The Americans had turned the ocean into a listening weapon, and the Japanese into whispers fading beneath the waves. But even this dominance was only the beginning. In 1945, the Americans would unveil a device that made every previous sonar seem obsolete. One capable not just of hearing, but of seeing beneath the surface. A weapon so advanced, it would redefine undersea warfare for generations. The sea rolled dark and heavy beneath the gray dawn. On the decks of USS Heermann, sailors stood in silence, scanning the horizon. The invasion of Okinawa was about to begin, the largest amphibious operation of the Pacific War. Beneath them, the ocean seethed with invisible threats. Every wave, every shimmer of foam might conceal a Japanese submarine waiting for revenge. But for the first time, the Americans weren't afraid. They had something new, an acoustic eye that could see through the deep. Pacific Fleet Operations Log, March 1945. It was called the QLA sonar, the underwater eye. Developed by Western Electric and the Naval Research Laboratory, this device transformed sound into an image, a real-time display that mapped the ocean floor and anything moving above it. It wasn't just a ping anymore. It was a picture. Operators could now track targets even during attack runs, no longer blinded by the noise of their own depth charges. Bureau of Ships Technical Report 1945. The Japanese had no idea this existed. To them, sonar was still something that vanished the moment an explosion shook the sea. Their submarines dove deeper, believing silence could save them. But now silence betrayed them too. The QLA's range recorder captured the faintest echoes, plotting their movement as glowing traces across the cathode screen. For the first time in history, man could watch another man die beneath the surface. Office of Naval Research 1945. By early April, the results were undeniable. In just 3 weeks, American destroyers and escort carriers destroyed over 20 Japanese submarines, a slaughter unseen in naval history. Each sinking was clinical, almost mechanical. Sonar located, Hedgehog fired, contact confirmed. The crews no longer relied on instinct or luck. The war had turned into a battle of data. U.S. Navy Action Summary, April 1945. For the Japanese, the psychological collapse was catastrophic. Survivors of the few remaining submarine crews described an ocean that seemed alive, one that could sense them, chase them, suffocate them. A captured ensign from RO-56 whispered, "The sea had ears, dramatized composite. Interrogation transcript. Okinawa, May 1945. The fear was real, and it spread through the Imperial Navy like infection. By mid-1945, Tokyo stopped using submarines for attack altogether. They became couriers, desperate freighters carrying rice, weapons, and oil through waters now ruled by sonar. Most never arrived. Each loss was another nail in Japan's industrial coffin. Imperial Navy Logistics Memo, May 1945. But while sonar silenced Japan's undersea fleet, its true power reached far beyond the Pacific. The Americans had discovered something profound, that information could destroy faster than firepower. A single sonar pulse, properly read, could command entire task forces. In naval warfare, knowledge had become the deadliest weapon. U.S. Naval Doctrine Review, 1946. In Washington, analysts studying post-war reports called it the Great Conversion. The war had begun with battleships, giants of steel and gunpowder, but it ended with laboratories and listening posts. Engineers, not admirals, had tipped the balance. Scientists like Dr. Harvey Hayes, Dr. Leo Young, and Dr. Harold Edgerton had become the silent generals of the deep. War Science Digest, 1946. Even after Japan's surrender, the echoes of their invention continued. The Cold War dawned on a divided world, and sonar, perfected through Pacific blood, became the first line of defense against a new enemy, the Soviet submarine fleet. The same QLA sets, upgraded into the QHBJ and SQS series, now guarded the Atlantic, mounted on sleek destroyers and nuclear-powered hunters. Naval Ordnance Development Report, 1947, but victory carried its own burden. Thousands of men who had lived by sonar found peace difficult. The silence of post-war life felt deafening after years of pings and explosions. Some described hearing phantom echoes in their sleep, the ghostly sound of submarines they once chased. Psychologists called it sonar echo syndrome, an unseen wound of modern warfare. U.S. Veterans Medical Report, 1948, Japan, too, never forgot the sound. When its Navy was reborn under American supervision in the 1950s, its first priority was sonar. Engineers trained in Yokosuka under U.S. advisors studied the same blueprints once used against them. They built better systems, quieter hulls, better hydrophones, determined never again to be blind beneath the sea. Japanese Maritime Self-Defense Force Technical Memo, 1953. Still, the lesson of 1944-45 lingered. In war, hearing meant surviving. The Americans had mastered the invisible. By turning sound into weaponry, they reshaped every ocean on Earth into a battlefield of echoes. Naval Acoustic Research Journal, 1954. The legacy of sonar reached far beyond the Navy. Its technology inspired post-war breakthroughs in oceanography, medicine, and exploration. The same principles used to destroy submarines were later used to map the seafloor, to study whales, and to see unborn children through ultrasound. The same pulse that once meant death now revealed life. Scientific American, 1955. But at its core, the story of sonar remains a story of men, those who built it and those who died because of it. The American engineers who calibrated frequencies late into the night. The sailors who listened until their minds blurred. The Japanese crews who waited in silent terror for the next ping. They were all part of the same rhythm, a human heartbeat echoing through war. Naval Archives Oral History, 1956. By war's end, over 130 Japanese submarines had been sunk, most by sonar-guided attacks. Japan's last operational boat, I-373, was destroyed on August 14, 1945, the very day before Emperor Hirohito announced surrender. Its final distress signal faded into static. The destroyer that heard it, USS Spikefish, logged a single note. Contact lost. War over. U.S. Navy Logbook, UG 1945. In the years that followed, naval strategists tried to explain what had truly won the undersea war. Some credited industrial production. Others pointed to intelligence, training, or luck. But the old sonar men disagreed. They said it was something simpler, a union of science and patience. We listened longer, one veteran said. Dramatized composite. Veterans Symposium, 1962. That's what warfare had become, a contest of awareness. The side that could perceive first, react first, think first, would always win. And in that sense, Sonar was not just a weapon, it was a prophecy. From the cold depths of the Pacific to the corridors of the Pentagon, it whispered a timeless truth. In modern war, knowledge is the sharpest blade. The unseen, the unheard, decides who survives. Pacific War Naval Conclusion Report, 1946.